Okay, gang. Hopefully, everybody had a good weekend and ready to move on after doing the calculations. I know some people have been saying they're having some issues. Again, we're not allowed to interact live with you guys, so some teachers are doing it. That's kind of going against what we're supposed to. So I won't do live interaction. So if you do have questions, just send them. I can keep going over example after example after example, whiteboard, video wise, whatever. Just send those requests. We got a few from the last one, so I'll probably have a few more as we go along. We're going to look at 6.6 in this video, which is percent composition. So what that means is if we know the masses of the elements in a compound, then we can determine the ratio that we want to have and eventually get us to our chemical formula. So the percent composition we're looking at is the percent by mass of each element in the compound. Now, this isn't to say that if it's 60% carbon and 40% oxygen by mass, that that's also the same as the ratio of atoms in that compound. That's not the case at all. All it is the makeup by mass. So if you took, for example, you took 3 samples and one had a mass of 2 and one had a mass of 4 and one had a mass of 6 grams. And then you broke down how much carbon was in each one, how much hydrogen was each one, how much oxygen was each one. What you would find is that the percent of carbon in each of those compounds, the 2-gram sample, the 4-gram sample, the 6-gram sample, the percent would always be the same. So you could do as many samples as you wanted. You would always find in a particular one that carbon is 40% of that particular sample that you have. And it would be the same, no matter how much of the sample you have, it's always going to be 40% carbon. So pretty easy to figure out how you're going to do that. Or if you want to figure out the percentage, it's like a percentage on a test. So if the sample weighs 2 grams and 0.0 or 0.8 of those is carbon, then it would be 0.8 divided by 2 times 100%, 40%. Okay, so just the same way you would figure out what your mark on a test was, it's the same thing here. The amount of carbon divided by the total of the compound times 100%. So in knowing that, what we're going to see, and because we could take 15 different samples and they would all come out with, in this particular case, 40% carbon every single time by mass, what that means is that it creates a law, and that law is called the law of definite proportions, which means elements in a compound are always present in the same proportion by mass. So if you took water, okay, it doesn't matter how many samples of pure water you take from wherever you take them. If it's pure water and we calculate the percentage by mass of hydrogen, every sample you take, that percentage is always going to be the same. Always, 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 always for water. Same thing about if it was carbon and carbon dioxide or whatever. For that particular compound, the percentage composition is the same no matter where you take your sample from. So I do have an example here that we can go through together from our book. So 500 milligram aspirin contains 300 milligrams of carbon, 8.08 milligrams of hydrogen, and the rest is oxygen. What is the percent composition? Okay, so if we know that, now we got to check our units, and that's the key. So in this, always check and make sure we're dealing with identical units. So we've got the sample is 500 milligrams. The carbon is 300 milligrams, so we can use that. Percent of carbon would be 300 milligrams divided by 500 milligrams. Units would cancel, times 100%. 60%. Okay, just like you would do it as 300 out of 500 times 100% is 60%. So the other part is the hydrogen, 8.08 milligrams divided by 500 milligrams times 100%, 1.62. And then the last one you would have to figure out how much, first of all. Okay, how much of it is oxygen. So you just subtract 100 minus the 60 found minus the 1.62. 38.38. Okay, so that would be our percentage composition for this particular compound, for which is our aspirin tablet. So there's lots of different ways that you can do this particular one. This is one we can do any compound. We can break it down. Sometimes they'll ask you to do like that. Oh, the remaining is, or they'll give you a mass. If they give you the mass, you just do the division again. So really shouldn't be a big surprise. Sorry, just wobbling around here. That's that one. Let's look at the second one, where if they tell us. Chemical formula. Ca bracket OH2. I'm sure all of you would know that if you had to name that, it'd be called calcium hydroxide. And you can count the total number of atoms: 1 calcium, 2 oxygen, 2 hydrogens in that particular one. So step one, in order to find the percent composition, right? That's what we want, the percent composition. Step one is the molar mass of CaOH2. Okay, we want the percent composition. First thing we're going to do, we've got to find the molar mass. So I'll let you do that calculation on your own, but it will end up coming out to 74.10 units in this one. Units or grams per mole, but we're using units because we're using formula units here. So then step two is the percent of, let's use calcium first. And calcium is 40.08 divided by 74.10. Okay. So these numbers. 40.08, I get that from the periodic table. That's the mass of calcium. 74.10 is the molar mass that we determined, which would be 40.08 plus 2.02 plus 32. That's how we get to 74.10. Okay, so we've got that one. We do the division, and it comes out to 54.09%. Step three is the percent of, let's say, hydrogen, which would equal, now here's the key that you got to watch here. Remember, it's 2.02 divided by the total 74.10. And that one is, sorry, 2.73. Okay, so here's the key, and this is where people make mistakes sometimes. When we do this particular one, it's 2.02 because there are 2 hydrogens. There's 2 hydrogens in CaOH2. So there's 2 times 1, which is 2 hydrogens, which means your total mass of hydrogen in the compound is 2.02, not 1.01. It was just 40.08 because there was only 1 calcium atom. And then, obviously, the last part, you can call it step 4. The percent of oxygen is 32 divided by 74.10 times 100%. And that's going to give us 43.18. Okay, so same thing. Same rule over here applies when we're finding percent of oxygen. 32 over 74 because there's 2 hydrogen atom, or sorry, 2 oxygen atoms in this particular compound. So you got to make sure you account for that in the total. The other way we could have found the percent of oxygen, real simple. 100 minus the amount we found for calcium minus the amount we found for hydrogen. The remaining percentage would be the oxygen. Okay, so those are hopefully straightforward. And I'm going to give you a second one today as well attached, but that's it for percent composition. Okay, so any questions? Again, the easiest way is if you put them on the Hangout. That way I can post it to the Hangout and everybody can see it, so you can look at what they have and what I have. Like I said, I strongly recommend giving your steps what it is you're doing one by one by one as the best way of solving it, but that's just me. So